In this video, we shall be looking at the demand equation, what is sometimes known as demand function. Specifically, we shall be covering three things. First, we will explain very briefly the meaning and nature of the demand function. After that, we will attempt a derivation of a demand equation or a demand function from a given demand schedule. And finally, we would attempt a transformation from the traditional demand function to the inverse demand function, whereby price is being expressed as depending on, among other things, quantity demanded of a commodity. In the simplest of terms, a demand function or a demand equation can be seen as the mathematical representation of the demand schedule. And from our previous discussion, we understand that the demand schedule is a tabular representation of the various quantity and price pairs in respect of a particular commodity which consumers of that commodity are willing and able to purchase at various prices. To explain the nature of a demand function or a demand equation, we have to take a lead from the equation of a straight line. And in the equation of a straight line, we have both the dependent variable and the independent variable. And we can express this equation of a straight line as y equals to mx plus b, whereby y is the dependent variable and x is the independent variable. M in this equation is the slope, which shows us how y changes as a result of a unit change in x, while b is known as the y-intercept. Like I said earlier, that the coefficient b represents the y-intercept, and this intercept shows us the point on the graph whereby the equation of a straight line crosses over the y-axis. Okay, from the given equation of a straight line above, we can deduce the demand equation form simply by using the alphabets that are closely related to demand. Hence, we can have Q equals MP plus B, where Q represents quantity demand and P represents the price, while M represents the slope. And this slope is not other than the rate of change in Q as a result of change in P. Hence, slope represents change in Q over change in P. While B represents the Q intercepts, and it shows us the point on the graph where the demand function crosses over the Q axis. Now, let us attempt a derivation of the demand equation. And like I said earlier, that we cannot attempt a derivation of the demand equation except we have a demand schedule, because it is the demand schedule that we can transform into a demand equation, just the same way we can as well transform the demand schedule into a demand curve. So for us to attempt a derivation of a demand function, let us assume that at various prices of apple, the consumer of apple is willing and able to purchase various quantities of apple. Let's say that when the price per unit of apple was 100 naira per apple, consumer was willing to consume, let's say, 60 units of apple. And when the price of apple increased from 100 naira to 150 naira per apple, the consumer was willing to purchase 40 units of apple. When the price increased further from 150 to 200 naira per apple, consumer was willing and able to purchase 20 units of apple. While when the price increased further from 200 to 250 naira per apple, the consumer was not willing to purchase any apple at all. To derive a demand function from the above demand schedule, we have to first and foremost state the equation form of the demand function. And the equation form of the demand function says that Q equals to MP plus B. M is the slope of the function, YB is the intercept, and Q is quantity demand, YP is the price. We can further restate this equation into the form Q equals to B plus MP. And in this form, nothing changes, just that we now have the intercept before the slope. So having stated the equation form of a demand function, we are now going to derive the slope of the equation. And like I said earlier, the slope of the equation represented by M shows us the change in Q as a result of change in P. So slope is going to be represented by change in Q all over change in P. And how are we going to have our change in Q. Change in Q is going to be represented by new quantity, which is new Q, minus old quantity, which is old Q. And we are going to have our change in price to be represented by new price, which is new P, minus old price, which is the old P. So for us to get new quantity and old quantity, all we need to do is to come to this demand schedule and take any two pairs. For instance, we can take these two pairs here, so that when we come to the quantity, we have that the old quantity here is 40. Let's call old quantity Q1 as 40, and let's call the new quantity 20. And we can have the old price as 150. Let's call it P1 as 150, while the new price is now 200. By plugging in these quantities and prices into the slope equation, we have that M equals to change in quantity all over change in price. And change in quantity, we have that Q2 minus Q1 all over P2 minus P1. And this is going to give us, our Q2 is 20, while Q1 is 40. It will give us 20 minus 40 divided by P2, which is 200, minus P1, which is 150. So that our M is going to be 20 minus 40 is going to give us minus 20 divided by 20 minus 150, which is going to give us 50. And our M is going to be minus 20 divided by 50, which is going to give us minus 0.4. For the sake of emphasis, let us equally take another two price quantity points and try to derive the slope of this function. Let's now take the points between 20 and 0. In this case, we are going to have that the old quantity, which we are going to refer to as Q1 here, is 20, while the new quantity, which is Q2, is 0. And the price associated with this quantity, the old price is going to be P1 is going to be 200, while the new price P2 is going to be 250. Remember that M, which is slope, is being given as change in quantity all over change in price. And change in quantity is being represented by new quantity minus old quantity, which is Q2 minus Q1, while change in price is being represented by new price minus old price, which is P2 minus P1. If we substitute these values here, we are going to have that our M is going to be Q2 minus Q1, and Q2 is 0 minus Q1, which is 20, divided by P2 minus P1, and P2 is 250 minus P1, which is 200. So we're going to have minus 20 divided by 250 minus 200 divided by 50, which is equally going to give us minus 0.4. So in essence, the slope of this equation using the demand schedule above is minus 0.4. Having obtained the slope coefficient for this demand equation, the next thing to do is to obtain the intercept. And for us to obtain the intercept, we need to restate the demand equation form, which is Q equals B plus MP. And from what we've done, we already have our M to be minus 0.4. We already have series of prices and series of quantities. The only thing we don't have is the intercept coefficient, which is the coefficient for B. So for us to get B coefficient, what we need to do is to take any price quantity pair from the demand schedule and do our substitution. We can take 160, or we can take 150 and 40, and we can take 250 and 0. Either of these price quantity pairs we choose is going to give us the same coefficient for the intercept. Let's take the first price quantity pair, where price is 100 naira per apple and quantity is 60 units of apple. For us to obtain the intercept, all we need to do is to do a substitution. Quantity is 60, YB is what we don't know, plus M, and our M has already been obtained to be minus 0.4. And it's going to be multiplied by price. Our price is 100. By opening the brackets, we are going to have that 60 equals B plus minus 0.4 multiplied by 100 is going to give us 40 minus 40. So we have that 60 equals B minus 40. Hence, we have that our B equals, can take 40 here, 60 plus 40. So the coefficient of our B is going to give us 100. For the sake of emphasis, let's equally take other price quantity pairs from the demand schedule above. Let's take 250 and 0 quantity, when the price was 250 and quantity demanded was 0, and then substitute into the demand equation so we can obtain the B coefficient. And remember that from our demand equation form, we have that Q equals to B plus MP. And we already have our M as minus 0.4. Now we have our Q as 0 and we have our P as 250. So by substitution, we are going to have that Q equals B plus minus 0.4 multiplied by P, which is 250. Now opening up the bracket, we are going to have that 0 equals B plus minus 0.4 multiplied by 250, that is plus minus 100. So 0 equals B plus minus 100. And we can move 100 this side, so we can have that our B equals 100. Now, having obtained the coefficient for the slope and the coefficient for the intercept, where we have that M, which represents the slope, is minus 0.4, and intercept, which is represented by B, is 100. We are going to impute these coefficients into the demand equation form, and the demand equation form says that Q equals to B plus MP. And now we have that our B is 100, so Q equals to 100 plus, and our M is minus 0.4 minus 0.4 P. By opening up the bracket, we have that Q equals to 100 minus 0.4 P. And this is the demand function in its conventional form. Having estimated the conventional demand function like we have it here, the next point is now to proceed with the transformation of this demand function into the inverse demand function, wherein price is going to be expressed as a function of quantity demand instead of quantity demand being expressed as a function of price.